In this example, we want to use logarithmic differentiation to find a couple derivatives. Part A says f of x equals x to the power of 10x. And a clear giveaway that you want to use logarithmic differentiation is when you have these x's up in the exponent. Right, the power rule doesn't work there, so we need to use logarithmic differentiation to get those x's down. Why doesn't the power rule work? Well, we have the power rule for two cases, x to the n where n is an integer, and we now have it for x to the r where r is a real number. But x to the x is neither of those. Okay, so we have to do a little work. Do not just use the power rule on these. That's a quick way to lose all the points. Let's bring up the steps to use logarithmic differentiation. So part A here, we have step 1, we write the function as y instead of f of x. So what that means is we just write this as y equals x to the power of 10x. Okay, step 2, take the natural log of both sides. ln, this would actually work with any log. It doesn't have to be natural log. Natural log y equals natural log x to the 10x. What this does is we can then use the properties of logarithms. This is step 3 to bring that 10x down to the front. So then we have natural log of y equals 10x natural log x. Step 4, we take the x derivative of both sides. Okay, when we take the x derivative of the left side, 1 over y is the derivative of natural log, but this is with respect to x, not with respect to y, so we need to use the chain rule and tag on this extra y prime there. Okay, equals, here we'll use the product rule. Recall from the product rule that the derivative of ab is a prime b plus b prime a. So a prime derivative of 10x is 10 times b, natural log x. All right, plus b prime derivative of natural log is 1 over x times a, 10x. Oh, look, we have a little bit of cancellation here too. Those x's cancel. All right, step 5, solve for y prime. So y prime then is y times 10 natural log x plus 10. I'm going to rewrite that as 10y times natural log x plus 1, just makes it look a little spiffier. And finally, step 6, we substitute the original y equals f of x in for y. Well, let's go all the way back up to the top here. This was our original y equals x to the 10x. Okay, so we substitute that in for our final answer, 10x to the 10x times the quantity natural log x plus 1. And there is our derivative. Moving on to part B. For f of x equals the quantity 1 plus x squared to the power of sine x, first we write this as y equals the quantity 1 plus x squared to the sine x. Okay, now natural log of both sides. That's what's going to help us get that natural log out of the exponent there. So down it comes. The whole sine x is going to come down to the front. So that gives us natural log of y equals sine x times natural log 1 plus x squared. Okay, now we hit both sides with the derivative. On the left side, derivative of natural log y is 1 over y prime, because this is the derivative with respect to x. So the chain rule tells us we have to add on that extra y prime. You can think of this as natural log u would be 1 over u times u prime. Same thinking there. On the right side, we have a product, so we'll hit this with the product rule. Sine x will be our a. Natural log quantity 1 plus x squared will be our b. So the product rule gives us a prime b, so derivative of a prime sine x is cos x times b, we just leave alone, natural log 1 plus x squared, plus b prime. All right, derivative of natural log 1 plus x squared is 1 over 1 plus x squared. Don't forget the chain rule. We have to multiply then by the derivative of that inside part, which is 2x. That's b prime, and then times a sine x. Next, we solve for y prime. That's what we're looking for after all. So that gives us y times the quantity cos x, natural log 1 plus x squared, plus, let's write this as 2x sine x over 1 plus x squared. And finally, we substitute our original f of x in for y. Recall all the way back in the beginning that y was the quantity 1 plus x squared to the power of sine x. The answer is so long, I'm going to need to scroll down a little bit even. Some of these logarithmic differentiation answers get very long. So we have 1 plus x squared to the power of sine x, all times all that stuff we had before. Cos x, natural log 1 plus x squared, plus 2x sine x over 1 plus x squared. Give it a quick looking over to see if we can simplify anything. In this case we can't, so it looks like this is our final answer.